Hey guys, this week we're going to be focusing on box and whisker plots. So we're going to talk about how to create them, but then the main things that we're going to be focusing on are how to interpret them once they've already been created, and then how to compare two different box and whisker plots. So today's video is mainly just going to be kind of a basic review. Some of this you should have already seen in 6th grade, and I know we've reviewed it in our warm-ups throughout the year, but this is just going to kind of refresh our memories on exactly what box and whisker plots are. So let's go ahead and get started with some of the basic vocabulary things that you need to know. So first of all, what is a box and whisker plot? So a box and whisker plot is a diagram that summarizes data by dividing it into 4 equal parts. So up here you can see an example of a box and whisker plot. So it divides it into 1, 2, 3, 4 parts. Now I know it says the word equal, and you might be thinking, well, those 4 sections are not equal sizes, but we'll get to that in just a minute. But these 4 equal parts are called quartiles. So if you think about the word quarter, like a quarter that's 25 cents, there are 4 quarters in a dollar. So a quarter means 1/4. Therefore, each quartile contains 1/4 or 25% of the data. So even though the sizes of these sections may be different, each of these contains exactly 25% or 1/4 of your data. Towards the end of this lesson, we'll talk about what the lengths of those different sections represents. Okay, the lower extreme is the smallest number in the data set, which is pretty much self-explanatory, so that would be the lowest number in the set. Okay, the upper extreme is the largest number in the set, so that would be this value here. Okay, the lower quartile is the median of the lower half of the data. Okay, so this line right here in the middle represents the median. So the lower quartile is the median of the lower half of the data. So it's the number that's in the middle when you look at just the lower half. So it's the left end of the box here. That's the lower quartile. The upper quartile is then the median of the upper half of the data. So this line right here, the right end of the box, represents the middle number in the upper half of your data. Okay, the interquartile range is the difference between the upper and lower quartile. So that means you would subtract your upper quartile minus your lower quartile. So the length of the box from one end to the other, that represents your interquartile range. Okay, now let's look at the steps for actually creating a box and whisker plot. So we're going to go through these together one step at a time. So step 1, order the data from least to greatest. So let's look at our data set here. It says high temperature. So we have a list of temperatures here over a given period of time. First, we want to list those from least to greatest. And I'm going to have to go back so I can get my pen. Okay, so when we list those from least to greatest, we're going to have 65, 67, there are 2 68s, 70, 71, 72, 73, 74, 75, and 78. So I just barely did fit them all in there. Okay, now once we have them listed from least to greatest, let's go back up and see what step 2 says. So step 2 says underline the extreme value. So that's the lower extreme and the upper extreme. So my lower extreme is 65. My upper extreme was 78 degrees. Okay, step 3, circle the median. So Ms. Winters reviewed this with you in last week's module, how to find the median. So as we go through and eliminate the left and right sides, working our way to the middle, when we get to the middle, there's just one number in the middle, which is going to be 71. So 71 is the median. Okay, step 4, put a triangle around the lower and upper quartiles. And let's look at what this note says. It says if there's only one number for the median, you do not include it when finding the upper and lower quartiles. Well, that's the situation that we're in. We do only have one number for the median. So we don't include that. So I'm going to put an X over that just as a reminder. That doesn't mean that that number disappears from our set or anything. It just means I want a reminder that I don't use that. So I'm going from 65 to 70. So as I work my way in, I can eliminate the 65 and 70, the 67, and this 68. And so then this first 68 right here is going to be the lower quartile. Now we're going to do the same thing on the right side. I don't include the 71. I'm just going from the 72 up to the 78, working my way in, crossing them out one at a time. And then when I get to the middle, I have 74. Okay, so this is the lower extreme. I'm just going to use these abbreviations. This is the lower quartile. This is the median. This is the upper quartile, and this is the upper extreme. Okay. Now we'll look at the next example about what to do when there are two numbers for the median. So we'll come back and read that part in just a minute. Now, once I know those 5 values, now I'm ready to go and create my box and whisker plot. So I'm going to use these 5 numbers that I identified and put dots above the number line at each of those places. So 65 was my first number. Okay, 68 is the lower quartile, so that's going to be right about here. 71 was the median, so that's going to be right about here. 74 was the upper quartile, so that'll be right about there. And then 78 was the upper quartile, which should be right about here. Now, the middle 3 points, I'm going to put a box around those. Okay, where my median was, I'm going to draw a line at that point, and then I'm going to extend a line out to my extreme values, and those are going to be the whiskers. So this middle box here, okay, represents 50% of the data, and then this whisker represents 25%, and then this whisker also represents 25%. So that's just kind of the basics of how to create a box and whisker plot. So again, if you go back to this visual right here up at the top where everything is labeled, this is a pretty nice summary of all of the different parts and pieces that you need to know. Okay, now let's look at example 2. We have a list of workers' ages, so following those same steps from the previous slide. Step 1, order the data from least to greatest. Okay, so we're going to do that step together. Hopefully I can fit all of it in this space here. So 23 was the youngest person, then we had 24. Next would be 29. Then 38, then 45, 51, 55, and 58. So we took care of ordering them from least to greatest. And a lot of times students actually forget to do that, and they will just create their box and whisker plot based off of the data in random order here. So don't make that mistake. Make sure that you put them in order from least to greatest first. Otherwise, everything after that is going to be off. Okay, step 2 is to underline the extreme values. So we have 23 and 58. Okay, as I'm getting these answers, we'll go ahead and fill them in the answer blanks here. So lower extreme is 23. That was the youngest person. Upper extreme, 58. That was the oldest person in the group. Okay, now let's go back and see what is our next step. Step 3, circle the median. So let's go and do that. Okay, working our way in from left to right, going to the middle and eliminating. This is a situation where when we get to the middle, we actually have 2 numbers for the median. Okay, so you worked on last week what to do in that situation. So we're going to add those and divide by 2. So when we do that, when we add 38 plus 45 and then divide by 2, we get 41.5. So the median is 41.5. Okay, now Let's go to step 4. It says put a triangle around the lower and upper quartiles. Well, this is the other situation. So let's read what it says to do there. If there are 2 numbers for the median, you do include the numbers when finding the upper and lower quartiles. So what that means is I do want to include this 38 in the lower half when I'm finding the median of the lower half. And I will include this 45 when I'm finding the median of the upper half. So what I like to do in this situation is just draw a line down the middle to kind of remind myself that I am going to use the 38 on the left side and I will use the 45 on the right side. Okay, so if I'm going from 23 to 38 and I want to find what's in the middle, well, actually, when I get to the middle, there are 2 numbers, 24 and 29. So I'm going to put my triangle right in between those numbers. And just like you would for the mean, I'm going to add those and divide by 2. So when I add 24 plus 29 and then divide that by 2, I get 26.5. So the lower quartile is 26.5. Okay, now we're going to do the same thing for the upper quartile. I'm going to go from this 45 to 58, and when I work my way in, the same thing is going to happen. I have 2 numbers in the middle, 51 and 55, so I'm going to put my triangle right in the middle there. When I add 51 plus 55 and then divide by 2, I get 53, so the upper quartile is 53. Okay. Now that I have those 5 answers, those are my kind of key numbers that I need to create my box and whisker plot. Let's go ahead and do that now, and then we'll come back and answer these last 2 questions once we finish our box and whisker plot. Okay, so the lower extreme was 23, so I'm going to come put a dot at 23. Okay, my lower quartile was 26.5, so that's going to be right about here. My median was 41.5, so that's going to be right here. My upper quartile was 53, which is going to be right there, and then my upper extreme is 58. Now we're going to put a box around the middle 3 points, going all the way from the lower extreme to the upper extreme. Draw a line at the median, and then extend my whiskers out to the extremes. Okay. Now, let's go back and answer the last 2 things that they asked for. So they asked for range. You worked on this in last week's module. So for range, we're going to subtract the highest number minus the lowest number, 58 minus 23, and that's going to give us 35. Okay. Then interquartile range, I'm going to subtract upper quartile minus the lower quartile. So we're going to do 53 minus 26.5, which actually comes out to be 26.5. Now, you may be wondering or noticing that the lower quartile and the interquartile range answers were exactly the same. That's just a total coincidence for this specific data set. That definitely will not always be the case. It's just a coincidence on this one. Okay. Okay, so that's it for that slide. So that covers creating a box and whisker plot yourself, not really doing too much interpreting yet. Now on this last slide, we're going to look at a box and whisker plot that has already been created for us, and then start looking at some interpreting pieces that we need to know. So it says the box and whisker plot was created based on the ages of teachers at AG Middle School. Now, they didn't tell us how many teachers were in this group. They didn't give us that information, but we do still know some key pieces of information based on the box and whisker plot. So there's still a lot of questions that you can answer just by viewing the box and whisker plot without actually knowing what every single number in the data set was or how many numbers there were. Okay, so some things that we can answer. The lower extreme, so that's going to be the lowest number in the data set. So in this case, that would represent the youngest person. So it looks like the youngest person of the teachers at this school was 23 years old. So the lower extreme is 23. Okay, now I'm going to go to the upper extreme. So that's going to be this far end of the whisker over here, and it looks like that's at 59. So that means the oldest teacher in the group was 59 years old. Okay, now we can go ahead and answer range at this point. So that's going to be the difference between the upper extreme and the lower extreme. So subtracting 59 minus 23, and that gives us 36. So the significance of that number, it tells us how spread out the ages are. So there's a difference in 36 years between the youngest teacher and the oldest teacher. Okay, next, the median. So that's going to be the line in the middle of the box here. So it looks like that's at 34. So the median age was 34. The lower quartile is going to be the left end of the box here, which is at 26. So the lower quartile is 26. The upper quartile is the right end of the box right here, which is at 41. So the upper quartile is 41. Now the interquartile range is going to be the difference between the upper quartile and the lower quartile. So we're going to subtract the number from the right end of the box minus the number from the left end of the box, which is 41 minus 26. And that gives us, if we can move, yes, okay, that gives us 15. So the interquartile range is 15. Okay, now let's look at some specific questions that we've been asked below the graph here. First question says, what percentage of teachers are between the ages of 26 and 41? So let's back up for just a second and talk about percentages again. So in the beginning, in the notes, the fill in the blank part, we talked about each quartile being 25% of the data. So I think it's always helpful to go and fill in a reminder that this quartile is 25%. This quartile is 25%. This is 25%, and this is 25%. So even though the sizes of those quartiles are so different in this particular data set, it still means that 25% of the teachers were between 23 and 26. 25% of the teachers were between the ages 26 and 34. So let's go back to the question now. So it says, what percentage of teachers are between 26 and 41? Well, here's 26, here's 41. So I have two quartiles in that section, each of which are 25%. So 25 plus 25 gives us 50%. So that's an important fact to remember, is that the box represents the middle 50% of the data. So 50% of your data will always lie inside that box. So let's come back down here and answer that question. So 50%. Now it says the ages of the teachers in the first quartile are, and then there are two blanks. So we just want to kind of analyze visually, how does this look? So in comparison with the other quartiles, this one is a lot smaller, right? It's a lot shorter. Okay, what that means is the ages of the teachers in that group are more clustered together. Okay, so we're going to say the ages of the teachers in the first quartile are clustered together. So what that might mean is maybe there are a lot of numbers that repeat, okay, in that quartile. Again, we don't know exactly how many teachers' ages were in this data set. It could be 10 teachers, it could be 50 teachers. So we can just kind of predict that there were a lot of numbers that were repeated, or they were very close together in that section. Okay, the ages of the teachers in the fourth quartile are more. So let's go back up. Okay, the fourth quartile, this section is a whole lot longer than the rest, right? What that tells me is that the numbers in this section of my data set were more spread out. So that quartile, the data was more spread out. Now, I will mention it could also mean that there was an outlier. Maybe the majority of the teachers are 45 or younger. Maybe there were a whole lot of data points right here in this section, and then you jump all the way from 45 to 59. We don't really know for sure because of the way the information was presented, but we could guess that most likely it just means the ages here are more spread out. It could also be that there was an outlier though. Okay, next question. What percentage of teachers are younger than 41? Well, let's go check. Okay, here's 41 right here. Younger than would be less than or to the left. So if I go to the left, there are 3 quartiles there. So 25 plus 25 plus 25 gives us 75%. So 75% of the teachers at this school were less than 41 years old. Okay, kind of summarizing some of the things that we just talked about. We're going to fill in the blanks in this last little paragraph here. It says the parts of a box and whisker plot are different lengths because of how spread out or clustered the data is. So if it's a short part, like the first quartile in this one, we said that means that the data is clustered. So it's very close together. Maybe there are a lot of numbers that repeat. If you have a long quartile, like the fourth quartile in this example, we said that that means that the data in that quartile are more spread out. Okay, so those are kind of the basics of box and whisker plots. Email your teacher if you have any questions about that, and then you'll have a little practice assignment to do from here. Thanks, guys. Hope you're having a good day.